Assalamu alaikum. My name is Samiullah from BS Mathematics. My ID is 20005070003. Now today my topic is redox reactions. First of all, we will describe what are redox reactions. A redox reaction can be defined as a chemical reaction in which electrons are transferred between two reactants participating in it. This transfer of electrons can be identified by observing the changes in the oxidation states of the reacting species. Types of redox reactions. The different types of redox reactions: decomposition reaction, combination reaction, displacement reaction, disproportionation reaction. First of all, decomposition reaction. This kind of reaction involves the breakdown of a compound into different compounds. For example, 2NaH give us 2Na plus H2. Next example, 2H2O give us 2H2 plus O2. All the above reactions result in the breakdown of smaller chemical compounds in the form of AB give us A plus B. But there is a special case that confirms that all the decomposition reactions are not redox reactions. For example, calcium carbonate give us calcium oxide plus carbon dioxide. Now, the second type is combination reaction. These reactions are the opposite of decomposition reaction and hence involve the combination of two compounds to form a single compound in the form of A plus B give us AB. For example, H2 plus Cl2 give us 2HCl plus O2 give us CO2. Next, 4Fe plus 3O2 give us 2Fe2O3. Now, the third one is displacement reaction. In this kind of reaction, an atom or an ion in a compound is replaced by an atom or an ion of another element. It can be represented in the form of X plus YZ give us XZ plus Y. Further displacement reaction can be categorized into metal displacement reaction, non-metal displacement reaction. Metal displacement reaction. In this type of reaction, a metal present in the compound is displaced by another metal. These types of reactions find their application in metallurgical processes where pure metals are obtained from their ores. For example, CuSO4 plus Zn give us Cu plus ZnSO4. The second one is non-metal displacement reaction. In this type of reaction, we can find a hydrogen displacement and sometimes rarely occurring reactions involving oxygen displacement. And the fourth one is disproportionation reaction. The reactions in which single reactant is oxidized and reduced is known as disproportionation reactions. For example, P4 plus 3NaOH plus 3H2O give us 3NaH2PO2 plus PH3. Okay, next, examples of redox reactions. First example, reaction between hydrogen and fluorine. In the reaction between hydrogen and fluorine, the hydrogen is oxidized whereas the fluorine is reduced. The reaction can be written as follows: H2 plus F2 give us 2HF The oxidation of reaction is H2 give us 2H positive plus 2E negative. The reduction of reaction is F2 plus 2E negative, 2F negative. The hydrogen and fluorine ions go on to combine in order to form hydrogen fluoride. Okay, next example. Reaction between zinc and copper. This is a type of metal displacement reaction in which copper metal is obtained when zinc displaces the Cu2 positive ion in the copper sulfate solution, as shown in the reaction below. Zn plus CuSO4 give us ZnSO4 plus Cu. The oxidation of reaction can be written as Zn give us Zn2 positive plus 2. The reduction of reaction can be written as Cu2 positive plus 2E give us Cu. Next, reduction potential of a half reaction. Each of the half reactions that make up a redox reaction has a standard electrode potential. This potential equals the voltage produced by an electrochemical cell in which the cathode reaction is the half reaction considered, whereas the anode is a standard hydrogen electrode. This voltage produced by the half reactions is called their reduction potentials. The value of the reduction potential of a half reaction is positive for the oxidizing agents that are stronger than H positive and negative for the ones that are weaker. Examples of the reduction potentials of some species are plus 2.866 volt for F2 and minus 0.763 volt for Zn2 positive. Applications of redox reaction. Redox reaction in combustion. Combustion is a type of oxidation reduction reaction and hence it is a redox reaction. An explosion is a fast form of combustion and hence explosion can be treated as a redox reaction. Even the space shuttle uses redox reactions. The combination of ammonium perchlorate and powered aluminium inside the rocket boosters gives rise to an oxidation reduction reaction. Redox reaction in photosynthesis. Green plants convert water and carbon dioxide into carbohydrates and their pieces to define a photosynthesis. The reaction is given as 6CO2 plus 6H2O give us C6H12O6 plus 6O2. Okay, reactants 6CO2 and 12H2O. Products C6H12O6 plus 6H2O plus 6O2. In the above reaction, we can see that carbon dioxide is reduced to carbohydrates while the water gets oxidized to oxygen and hence it is a redox reaction. The energy is provided by the sunlight for this reaction. This reaction is a source of food for animals and plants. Real life application of redox reaction. Production of some important chemicals is also based on electrolysis, which in turn is based on redox reactions. Many chemicals like caustic soda, chlorine, etc. are produced using redox reactions. Oxidation reduction reactions also find their application in sanitizing water and bleaching materials. The surfaces of many metals can be protected from corrosion by connecting them to sacrificial anodes, which undergoes corrosion instead. A common example of this technique in the galvanization of steel. The industrial production of cleaning products involves the oxidation process. Nitric acid, a component of many fertilizers, is produced from the oxidation reaction of ammonia. Electroplating is a process that uses redox reactions to apply a thin coating of a material on an object. Electroplating is used in the production of gold-plated jewelry. Many metals are separated from their ores with the help of redox reactions. One such example is the smelting of metal sulfides in the presence of reducing agents. Okay, thanks.